Hey guys, so today we're going to work through the test review for test 2. So I've screen shared it. You have it on Canvas and on my math lab. You can print it off. I've also had it in class every day this week for you to pick up as well. But what I'm going to do is I'm just going to work through every problem that's on here to show you how it's worked and how I expect it to be answered on the test itself. Remember, the test is identical to the review. The numbers change, but the order is the same. The type of questions are the same. If it's not on the review, it's not on the test. If it is on the review, it is on the test. So it's the best tool you have. It's not worth any credit, but it is the best tool that you have to review. All right, so number 1, solve the following inequalities and graph the solution on the number line. So number 1, there's 2 of them. There's A and B. Both of those are from section 1.7. So that's actually a chapter 1 thing, but anything is fair on any of the exams. So we have 3 times 4 minus 5x is greater than 30 minus 9x. So what you do here is we really work the problem just like we would if it was an equation. So I'm going to distribute my 3 in where it's 12 minus 15x is greater than 30 minus 9x. I'm going to get all my x's on one side and I'm going to get all my numbers on the other. So I'm going to get all my x's on the left and I'm going to move all my numbers over to the other side. So I'm going to add 9x over, which will give me a minus 6x. Then I'm going to subtract my 12 over, which will give me 18. Divide both sides by -6. Remembering that when you divide or multiply across an inequality by a negative number, you have to flip it. So instead of it being greater than, it's now going to be less than. 18 divided by -6 will give me -3. So x is less than -3. So I provide you a number line. Give me like 2 numbers before and a couple numbers after. So I have -5, -4, -3, -2, -1, and 0. So I need to graph x is less than -3 on this number line. And I do that by putting a parenthesis at -3, and I'm opening it towards the negative side because x has to be less than -3. And then it's anything there. Because x is less than -3 means we can get really close to -3, but we don't include it because it's simply less than. And that's how you would do that problem. Remember, I'm going to be erasing, but you can always pause the video if you need longer to look at one of my solutions. B says the absolute value of 2 times x minus 1 plus 12 absolute values less than or equal to 14. Again, this problem was done in 1.7. When we have the absolute value in our equation and it's an inequality, then what we do is we write the solution, that 14, we write -14, and it was less than or equals to, so we write less than or equals to, and we write everything that was in our inequality in the middle, just without the, or in the absolute value, and we write it in the middle without the absolute value. So I have 2 times x minus 1 plus 12, and then that is still less than or equal to 14. We get this compound inequality. So I wrote the equation exactly like it was without the absolute value. And then I tacked on this -14 less than or equal to over here on the right-hand side. The first thing I'm going to do is I'm going to distribute that 2 into my parentheses. So I have 2x minus 2 plus 12 is less than or equal to 14. 2x -2 plus 12 will give me a plus 10. Now I need to get x by itself, and I do that by subtracting 10. And just like with an equation or a regular inequality, if I subtract 10 here, I have to do it from now, instead of just the other side, I have to do it from all three sides. So and I'm going to subtract 10 from here, here, and here. So negative 14 minus 10 is a negative 24, is less than or equal to 2x, which is less than or equal to 4. X is not by itself yet. We still have that 2, so I'm going to divide all three parts by 2. So I get negative 12 is less than or equal to x, which is less than or equal to 2. So I'm going to come over here to my number line. I'm going to have negative 13, 12, 11, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. 1, 2, 3. I always go a little bit, oops, a little bit beyond on each of my numbers. So negative 13, negative 12, negative 11, negative 10, negative 9, negative 8, 7, negative 6, negative 5, negative 4, 2, 1, 0, 1, 2, 3, and 4. That way I can just have a good representation of what's going on my number line. Now it says negative 12 is less than or equal to x. So the other way to read that is x is greater than or equal to negative 12. So x is greater than or equal to negative 12 means we have a bracket at negative 12, but it's opening towards the right because x is bigger than it. So I know I'm going to go that way. But then next it says x is less than or equal to 2. So at 2, I have a bracket opening towards the left because x has to be less than or equal to 2. Notice that I'm going this way and I'm going this way. So that means I can shade in everything between those two brackets because they face each other. They open towards each other. There are cases where they will open outward, like shoot off towards negative infinity and shoot off towards positive infinity, and that is completely okay. That's just another solution set. So that's how you do number 1. Number 2. Number 2, A through E. So that's A through E. That's these first ones. Those are all from 2.3. F and G are from 2.4. And for number 2, it says, for the following linear equations, state whether the line has a positive, a negative, a 0, or undefined slope. So for A, we have x equals 4. Well, what is the slope for that? Well, if you don't know off the top of your head, maybe graphing it would help you. So if you graph it, 1, 2, 3, 4, x equals 4 is a vertical line at x equals 4. Vertical lines are always have an undefined slope. And that is because if you remember, slope is y2 minus y1 over x2 minus x1. But our x's aren't changing. Our x's are always 4. And so that means there's 0 change in the bottom. That means you have a number over 0. And if you have a number over 0, then it is undefined. So undefined slopes always look like x equals a number. The reverse of that would be B. B says y equals negative 2. Again, you could graph this if you wanted to. I'm going to graph it right here on the same little graph for you. Y equals negative 2 looks like that. Notice that we don't go up or down at all, so that means our slope is 0. And that is because if you look here, our y's don't change, but our x's do. So you would have 0 over some number, and any number that is like 0 divided by any number is still 0. So a 0 slope will always simply be y equals some number. It won't have anything else. So x equals a number is undefined slope, y equals a number is 0 slope. So let's look at the other ones to figure out those slopes. So C, we have y equals 3x plus 4. Remember, y equals mx plus b. That m is your slope, that number that's out in front. So if you have an equation written in y equals mx plus b form, you just have to look at what that m is. So for C, our m is 3. That's a positive 3. So we have a positive slope. That's all you do for C. For D, you have y plus 2 equals negative 1/3 times 4 minus x. Now this is not written in y equals mx plus b form. So I recommend getting it at least partially in y equals mx plus b form. And we do that by distributing that negative 1/3 into our fraction or into our parentheses. So negative 1/3 times 4 is negative 4/3. Negative 1/3 times negative x becomes a positive 1/3 x. So if I rewrote that, I'd have 1/3 x minus 4/3. Yes, I still have this plus 2 over here, but that's not going to affect my x, which is where my slope is. That's going to affect my b, my number out here. So really, I don't have to do anything else because now I can look at what my m is. My m is the number before my x, which is a positive 1/3. So D is also positive. So you have to be careful there because you might just look and say, well, there's a negative in front of my x, so it's negative. But because we have that negative 1/3 out there, negative times negative gives you a positive slope. If you look at E, we have y equals negative 3x plus 5. That's written in y equals mx plus b form. So that negative 3 tells me my slope is negative. Hopefully these are easy points for you on the exam. Now F says give a pair of parallel lines. Remember, parallel lines have the same slope. Now, I'm not expecting you to pick from A through E an equation and find its parallel line. That's not what I'm saying. I'm saying give me any parallel lines. So write an equation of a line. Y equals 2x plus 1. There's an equation. So that goes on your first line. Now I need to write the equation of a line that's parallel to that. Well, y equals, if they're parallel, they have the same slope. So it's 2x, and then instead of plus 1, I'm going to put minus 1. That is a pair of parallel lines. Did I just make them up? Absolutely. That's what you're supposed to do for F. So if parallel lines have the same slope, then perpendicular lines have negative reciprocal slope. Remember, this is from 2.4. So I'm going to use y equals 2x plus 1 as my first equation again. You can totally do that. But if I need the perpendicular, a line perpendicular to that, then I can't write 2x again. I have to write the negative reciprocal. So negative automatically tells you if it's positive, you're going negative, and if it was negative, you'd go positive. But then reciprocal means you flip it. So instead of 2, which can be written as 2 over 1, instead of 2 over 1, I'd now have negative 1 over 2x. And then it doesn't matter what else I put there because as y equals 2x and y equals negative 1/2x, those are perpendicular to each other. So make them up. Yes, I know on your copy, it says PARA instead of PAIR for perpendicular. I think I went from parallel to pair and wrote para, but perpendicular. So these are perpendicular lines. Okay. Number 3, they give us 2 points and they ask us a whole bunch of questions about those 2 points. So the first 2 that they ask us, part A and B, those are from 2.8. Okay, so part A says find the distance between these 2 points. Distance is in 2.8. Distance equals the square root of x2 minus x1 quantity squared plus y2 minus y1 quantity squared. So what does that mean? Well, what is our x2? Our x2 is -3, because remember, you just look at your points. This is 0.1, this is 0.2. So -3 minus your x1, which is 5, quantity squared, plus y2, which is 4, minus a -2, which is minus and a minus becomes a positive. So -8 squared plus 6 squared. -8 times -8 is 64. 6 times 6 is 36. 64 and 36 will give you 100. Square root of 100 is 10. Some of you might be saying, well, it's plus or minus 10. Well, that's true, except we're doing distance. And when we talk about distance, we just include the positive. So it's just, positive 10. So that was part A, and that's from 2.8. Part B is also from 2.8. Part B says find the midpoint of the line segment between these 2 points. So midpoint was x1 plus x2 over 2, and y1 plus y2 over 2. And those are given in parentheses because it's an ordered pair. The midpoint is a point given an xy form. So what is x1? Well, x1 is 5 plus x2, which is -2, or -3, excuse me, all over 2, comma, y2, or y1, which is -2, plus y2, which is 4, all over 2. 5 minus 3 over 2, comma, 2 over 2. 2 over 2, comma 1, which equals 1 over, or just 1, 1. So the midpoint of a line segment going through these 2 points would be the point 1, 1. And that is B. Part C says find the slope of a line that runs through those 2 points. Slope was in 2.3. Slope is y2 minus y1 over x2 minus x1. So y2 would be 4 minus y1, which is -2, all over x2, which is -3, minus x1, which is 5. Minus and a minus become a positive, all over -8. 6 over -8. They both have a 2 in common, so that'll reduce it down to 3 over -4. So the slope of a line that goes through those 2 points is -3/4. Now we use that information, sorry, I haven't moved around enough. We use that information, that slope of -3/4, in order to write the equation of a line going through those 2 points. That's part D. So we have 2 points. and we have a slope. If we have 2 points and a slope, then we can use point slope form. And I'm actually going to come over here to this side to do that. Point slope form was from 2.3. That was y minus y1 equals m times x minus x1. Now we don't use both of our points they give us here. We just use one of them. And it does not matter which one you use. I'm going to use the first point, that 5, -2, just because it's the first point. So y minus y1, well, y1 is -2, so I'm going to go ahead and change that to a positive. The slope, we just found slope was -3/4 times x minus x1, which is 5. I'm going to distribute that -3/4 in. So I have y plus 2 equals -3/4 x. And then a negative and a negative becomes a positive. And when you multiply fractions together, you multiply the tops. So that'd be 15/4. I'm going to subtract the 2 over. But when you subtract the 2 over, it becomes 2/1. I need to have a common denominator there, which would be 4. So I multiply both the top and the bottom by 4. So what I'm really doing is I'm subtracting 8/4. So y equals -3/4 x, and then 15/4 minus 8/4 will leave me a positive 7/4. And there is the equation of a line that goes through those 2 points. So, part E says I need to graph. You can do this a lot of different ways. These are not very nice numbers. I'm not gonna lie, they're kind of yucky. So which way would you like to do it? Well, you're not here, so here's the nice thing. Can I give you the cheat? Because if you were to graph this the way that we learned how to graph with lines, you would plot the B, and then you would use your slope to plot another point. But nobody wants to plot the point 7/4. That's gross. But what did they tell us at the very beginning of the problem? They gave you 2 points. What do you need to graph a line? You need 2 points. So what 2 points do I have? I have the point 5, -2. There's a point. And I have the point -3, 4. There's a point. So to graph that, I'm going to graph a line and connect those 2 points. You only need 2 points to graph a line. They gave you 2 points to start with. This is supposed to be 3 points. You just plot the 2 points they gave you, draw the line. Please don't make it too hard. That should be, everybody should get 3 points there. 3 points. All right. And then kind of going back to like what we did on the front of this page, it says find an equation of a line parallel to this line. Well, here's the equation that we got. So parallel would have the same slope. So parallel would be y equals -3/4 x. And then you could leave it like that, or you could put plus or minus any number you dream up. -4. That line has the same slope, so these are parallel. That's from 2.4. Part G, where you find a line that's perpendicular, is from 2.4 as well. So perpendicular would be y equals, and it's negative reciprocal. So negative reciprocal says, well, that was a negative slope, so now I'm going to have a positive slope. Reciprocal means I'm going to flip it. So instead of 3/4, I now have 4/3x, and I will just keep the -4 because it does not matter. But this is the equation of a line parallel. This is the equation of a line perpendicular. That's all you do. So let's move on. Graph some more. Number 4, you have two different equations that we are going to graph. Both of these on number 4 can be found similarly in 2.3. So y equals 4x plus 1. We need to graph this. Okay, so to graph this is written in y equals mx plus b. That b tells me my y-intercept. So my y-intercept is at 1. So I'm going to put that as my first point. From that point, I can use my slope to find my next point. So my slope is 4. Remember, that can be written as 4 over 1. And remember that slope is rise over run. That means I'm going up 4 and to the right 1. So I'm going to go up 4, 1, 2, 3, 4, and to the right 1 to plot my next point. I connect those 2 points, and there I just graph the equation of that line. I used my point intercept, like I used my y-intercept, and then I used my slope to plot my next point. If you don't like that method, you can always use your table method where you make an x column, you have your function column, and then you have your y column, and you can do that as well. I do not care how you graph it. I care that you include points and that you do graph it correctly. Let's look at B. B says y plus 2 equals -2 times x minus 3. Now this is not written in y equals mx plus b form, so we need to get it into y equals mx plus b form. So to do that, I'm going to distribute my -2 in. So I have y plus 2 equals -2x plus 6. I'm going to subtract over my 2. So I have y equals -2x plus 4. Now I can graph it. So y equals -2x plus 4. That tells me that my y-intercept is at +4. And then my slope is -2. That's -2 over 1. So that means I go down 2 and to the right 1. So I go down 2 and to the right 1. And then I connect those points. And there's the equation of my line. Remember, positive slopes, like our first example, they rise as you go from left to right. Negative slopes, like this example, they fall as you move from left to right. So those are quick ways to double check. Sorry, I didn't roll up. To double check your answers and make sure that you are doing them correctly, just as a quick view. Okay. The next problem is about circles. Circles we covered in 2.8. So number 5 is from 2.8. They give us the equation of a circle. It says x plus 1 squared plus y minus 1 squared equals 9. Part A says find the center of the circle and the radius of the circle. So the first thing you have to do is realize they gave you the circle in general form, which is lovely because from that we can find the center and the radius very quickly. Remember, the general form says x minus h squared plus y minus k squared equals r squared, where h, k is your center and r is your radius. So So if we have to find our center, our HK, then we look up here and we say HK. The one thing you have to be careful on is that our general form is a minus h, but this says a plus 8, like a plus 1. So is there a way to write plus 1 but with a minus? Yeah, we could say that that was x minus a minus 1. So then my h would be -1, and my k would be a positive 1. So you have to be a little bit careful there because they have a minus in the general form. So my center is -1, 1. And then my radius is r, but it says r squared is the general form. So if r squared equals 9, and I'm solving for r, I would take the square root of both sides, and I would get r equals 3. Again, we're not going to talk about the -3 because we're talking about distance. So my radius is 3. One, two, three, four, five. When you graph a circle, which is part B, what you do is you plot your center, so -1, 1, and then you use your radius to plot 4 other points to kind of make a circle. So I'm going to go up 3, 1, 2, 3. I'm going to start at my center and go to the right 3, 1, 2, 3. Start at my center and go down 3, 1, 2, 3. And then start at my center and go left 3, 1, 2, 3. I mean, that's what a radius does, is it measures the distance out to the edge of the circle. Then I connect my outer dots, and my circles never really look like circles. They look more like oblong squash things, but that's okay. As long as you have those points, it'll look fine. Like even on paper, I have an oblong circle, and that's okay. So those are from 2.8. You plot the center, you use your radius to plot the outside points, and you graph it. Flip over, and I will scroll up for you. So problem number 6. Problem number 6 says using the method of completing the square, which we did completing the square in chapter 1, and we do it in chapter 2 and 2.8, we need to put the following equation in standard form. So right here, we have the equation of a circle, and we need it in standard form. Standard form is what we had earlier. Standard form is the x minus h squared plus y minus k squared equals r squared. That's what we're trying to get to, but that's not what we're given. We're given x squared plus 6x plus y squared minus 4y minus 2 equals 10. That's what we're given. So what we need to do is we need to complete the square, but we complete it twice because we're doing it with a circle. So we're going to look at our x's separately from our y's, and then we're going to move that 2 over to the other side. I guess I'll make this blue. So I have x squared plus 6x, and then I'm going to put plus, and I'm going to put a blank. Then I have plus y squared minus 4y plus blank. Notice I have a blue blank and I have a pink blank. And that equals, well, I had 10 and then I added 2 to that, well, that equals 12. But I have plus blue blank plus pink blank, because that's how completing the square works. We have to put those blanks on both sides. Okay, so let's just look at the x. We have x squared plus 6, and we need to complete the square. Well, remember, completing the square says I had b, and my b in this case is 6. 1/2 b is 3, and 1/2b squared, well, that's 9. That 1/2b squared is what fills in my blank. So that goes in my blue blank, but that goes in on both sides. That's why I put those blanks in there. Sorry, I'm not moving around fast enough, so it thinks I'm not here. Okay, so let's look at y. Y squared minus 4y. My b is minus 4. So 1/2b is minus 2. So 1/2b squared is 4. So I put 4 and 4 into both of those spots. Now, the reason why I list out these is because then when I come to factoring, I have an x, and then this 1/2b is what goes inside there. So it's x plus 3 quantity squared. Then I have the plus. And then my y is y. And then what goes in there? My 1/2b, which is minus 2 quantity squared, equals, and then over there I had 12 plus 9 plus 4, which equals 25. That's how we complete the square twice to get the standard form of the circle. And from that, I could ask you, well, what is the center and what is the radius? And you'd be able to tell me because we just did that on the previous problem. Okay, so that's in 2.8. Now we're going to do algebra functions. We did that in 2.6. So number 7 is all from 2.6. We're given f of x equals 9x plus 4, and g of x equals x minus 1. And we're going to do all the different forms with it. So if we have f plus g of x, that's part A. We are just combining them. So we write f of x, which is 9x plus 4, and then we write plus g of x, which is x minus 1. 9x and x will give me 10x, and 4 take away 1 will give me 3. So you get 10x plus 3. F minus g of x, you write f of x, which is 9x plus 4, and then minus, and then I always tell you, put your g of x in parentheses. Because if you don't do that, you're not going to distribute that negative into both of the terms or all of the terms of your g of x, and you're going to get the wrong answer. So that's 9x plus 4. Distribute that negative in, so it's negative x plus 1. That plus 1 you would have had as a negative 1 if you didn't include the parentheses, and it would mess up your ending. 9x minus x is 8x. 4 plus 1 is plus 5. So we added our functions, we subtracted our functions. Now we're going to move on to multiplying and dividing our functions. F times g of x. You take your function f of x, which is 9x plus 4, and you multiply it by your g of x. Luckily for us, these are two binomials, which means we can FOIL them. 9x times x is 9x squared minus 9x plus 4x minus 4. 9x squared, negative 9x plus 4x would be a negative 5x, and then we still have that minus 4 out there. f divided by g of x, you take the function 9x plus 4 and divide that by x minus 1. They don't have any factors in common that we can eliminate, so that's literally all you have to do. You don't have to worry about eliminating anything else. So we added, subtracted, multiplied, and divided those two functions together. Now for number 8, this is also from 2.6, but this is composition of functions. This is where we take the functions and shove them inside of each other to come up with new functions. So I have f of x equals x squared minus 1, and I have g of x equals 4 minus x. And I'm asked to find f of g of x, fog, f of g of x. The way I like to write that is f of g of x, because that shows me exactly which function I'm shoving inside of which function. I am going to shove g of x right there inside of my f of x. So I'm going to write my function f of x, but every time I hit an x, I'm going to write g of x. So I have g of x squared minus 1. Instead of writing x squared, I wrote g of x squared. Well, g of x is 4 minus x squared minus 1. That's 4 minus x times 4 minus x minus 1. I'm going to FOIL. 16 minus 4x minus 4x is a minus 8x. Negative x minus, or times the negative x will give me a positive x squared. I still have that minus 1 out there. I am going to reorder these. I'm going to put my x squared first. Then I have a minus 8x. And then I have 16 minus 1. So that'll be plus 15. So there is my f of g of x. Next, you are asked to find g of f of x. That's where you take f of x and plug it in to g of x. Anywhere that there is an x. So what that means is I write my equation for g of x, I write 4 minus, but then instead of writing x, I'm going to write f of x. So that's 4 minus, well, what is f of x? It's x squared minus 1. Notice I had parentheses though, because that minus is going to affect everything inside of that g of x, or that f of x. So I'm going to distribute that negative in, where it's 4 minus x squared plus 1. Again, I'm going to reorder it to have my x squared first. And then I have 4 plus 1, which is plus 5. So that was f. We did f of g, this was g of f. Both of those can be found in 2.6. I'm going to scroll up some more for number 9 and 10. Number 9 is just determining if two functions are inverses of each other. We did this in 2.7. To find inverses of each other, we had to do f of g of x, f of g of x, and g of f of x in order to determine if they were inverses or not. Because remember, we want them both to equal x. If they both equal x, then they're inverses of each other. So let's look at A. A, we have f of x equals 6x minus 5, and we have g of x equals x plus 6 all over 5. So let's start by finding f of g of x. So we're going to take g of x and shove it into our f of x. So we have 6, and then instead of saying x, I'm going to say 6 times g of x minus 5. So that's 6 times x plus 6 all over 5 minus 5. Well, that's 6x plus 36 all over 5 minus, and then I'm going to go ahead and combine these. So that would be 5 over 1, so that'd be 5 over 5, so that's 25 over 5, which is 6x. 36 minus 25 is 11 over 5. Does that reduce down any further? No, it doesn't. So did we get x? We did not get x. So right there, right then and there, we're done. We don't have to do g of f of x because this didn't equal x. So we can know immediately that these are not inverses. And that's what you would write on that line that I give you. Write not inverses. But we're also done with that one. We don't have to do it the other direction. So that was nice. So let's look at B. B says f of x is 8 over x minus 6, and G is 8 over x plus 6. And we need to find f of g of x. That means I write my f of x, but anywhere that there's an x, I write in g of x. Okay, well that's 8 over, and then instead of writing g of x, I have 8 over x plus 6 minus 6. Don't let the fraction and the fraction terrify you. It's really not that bad because that plus 6 and minus 6 are going to go away. So that leaves you with 8 over x. And you might be thinking, well, how in the world do I reduce that? Well, think of it this way. What I'm saying is 8 divided by, so 8 divided by 8 over x. Well, when you divide by a fraction, what you really are doing is you are multiplying and you flip the second, you flip the fraction. So instead of dividing by 8 over x, I'm multiplying by x over 8, which gives me 8x over 8. The 8's go away, which gives me x. Hey, that's what I wanted to do. So that's a good start. So let's look at g of f of x. That's where I write the function g, but anywhere that there's an x, I write an f of x. Sorry, I was trying to say x and f of f at the same time. So that's going to be 8 over x minus 6, and then I have that plus 6 over there. I'm going to approach my fraction and a fraction the exact same way I did right here. So 8 divided by 8 over x minus 6 is what I'm saying for this part right here. Well, that's 8 times x minus 6 over 8. So that's 8 times x minus 6 over 8. My 8's go away. Just a little bit. So that leaves me with an x minus 6, and I still have that plus 6. Don't forget about it. Plus 6. Negative 6 plus 6 will just leave me with an x. I got f of g of x equals x, and I got g of f of x equals x. That means these are inverses. So on your line, you can write inverses or are inverses. But you have to show me the work. You can't just guess. You won't get full credit. Notice these are 5 points apiece. They're 5 points apiece because I expect to see work. If you just put inverses or not inverses, yeah, you have a 50-50 chance, I guess, of guessing correctly, but you're only going to get like 1 point for those. So that's definitely not worth it. And again, these were from section 2.7. That's where we dealt with inverses. So continuing with inverses is number 10. Number 10 gives us a function. And it says, find the inverse to this one-to-one function. It's nice that it specifies that it's one-to-one because one-to-one functions are the only functions with inverses. So what do we do for this? Well, from 2.7, you switch your f of x to y. Once you've done that, you will interchange your x's and your y's. So everywhere that there's a y, you write x, and everywhere that there's an x, you write y. Then you solve for your new y. You want to isolate it. So I'm going to subtract over my 5. I divide both sides by 2. I guess it doesn't really make that much difference to you if my light's on, does it? And then the last step is simply writing x inverse of x instead of y. That helps too. So that's how you find the inverse function. And that is the last problem on the practice exam. There's only 10 problems. So study hard, do this packet on your own. If you really want to test yourself on if you're ready, do the packet, like print off a new one or pick up another one from me in class or during office hours and set a timer. Set a 60-minute timer and see if you can complete the exam in 60 minutes or less. And if so, then you're probably ready. If not, maybe you need to figure out which of the problems is slowing you down or tripping you up. So that is it for test 2 review.